Hi students, today's topic is matter and properties. We're going to cover volume. First, let's define matter. Matter is anything that has mass, volume, inertia, and particular structure. These are the common properties of matter. Every matter has these properties. What is mass? Mass is a measure of quantity of matter present in an object, and also it's the measure of the inertial property. What is inertial property? It is the resistance to the change of motion. For example, an elephant is more massive. It has more mass than a man because it has more quantity of matter. So it is harder to change an elephant's motion. That means that the elephant has more inertia. What is volume? Volume is a measure of how much space it occupies. For example, think of a cylinder. When you put n times a circular, what do you get? A cylinder. So in general form, the volume will be equal to the base area times the height. So here my base is a circle as in this, and the height is h. If I say the area is a and the height is h, then the volume will be equal to base area times the height. So this is the general definition of volume. In order to apply this formula, the base and the top of the geometrical object should be the same. Can objects that are made of different materials have the same mass or the same volumes? Yes, they can, but under some conditions. Different materials may have same mass, but if they have the same mass, then they should have different volumes because they are different materials. If they have same volumes, then they should have different masses. Consider a ping pong ball and a golf ball, which are approximately the same volume. Can you compare their masses? You can say that the mass of a golf ball is bigger than the mass of the ping pong ball because the ping pong ball is denser. Now let's give the formulas for the regular shaped objects. The cube, the formula is a cube. How you get it? You have the base equal to a square. So from base area times height, the base area is the area of a square times height a, which give me a cube. A rectangular prism, it has a base of a rectangle. So the volume is equal to base area times height. The base area is a times b, you see here, times the height c. So you get the formula a times b times c. A cylinder, you have a base equal to a circle, so the volume is base area times height. The base area of the circle is equal to pr squared times h height, so you get the formula pr squared h. A cone, when you complete a cone, you get a cylinder. So cone is the volume of the cone is 1/3 of the volume of the cylinder. So you can say that the volume of cone is equal to the volume of cylinder over 3, which is equal to pr squared h over 3. The volume of a sphere is equal to 4/3 pr cube because it has no base area, so it has a special formula. Now do an example. Let's find the volume of this geometrical object. We have a half sphere, let's say volume V1, a cylinder V2, and a cone V3. V1 is equal to 4 over 3 pi r cubed over 2 because it is half. So when we take pi as 3, this cancel, 4 cancel to 2, and now let's find the radius. This radius is also equal to the radius of the sphere, equal to 2 centimeter. So 2 times 2 to cube, which is equal to 16 centimeter cube. Now the volume of sphere is equal to, from the formula, pi r square h, 3 times 2 square times the height, you see here 3. So I have 36 centimeter cube. The volume of the cone is equal to pi r square h over 3. The pi and 3 cancel each other, so 2 square times the height here, 4, is equal to 16 centimeter cube. So when I sum these values, I have got the result as 68 centimeter cube. What is the volume of airspace between the cone and the cylinder? These parts are empty. So as you will remember that the volume of cone is 1/3 of the volume of the cylinder. So how can we relate this? Then 2/3 of the cylinder is empty. So the empty part is equal to 2 over 3 times the volume of the cylinder, pi r square h. So pi and 3 cancel each other, 2 times 2 to power 2 times the height 4. I have 32 centimeter cube. The radius of the sphere is 2 centimeters. Here is 2. What is the volume of airspace between the sphere and the cylinder? These shaded parts are empty, and the volume of this empty part is asked. So you see that the empty part is equal to the volume of the cylinder minus the volume of the sphere, which is equal to pi r square h minus 4 over 3 pi r cube. Now p is equal to 3, r is equal to 2. You see that this is also equal to 2 centimeter because it's equal to the radius of the sphere, 2 to square times. Height of the cylinder is equal to, you see here that 2r, the diameter of the sphere, which is equal to 4 centimeters. So times 4, minus 3 cancel each other, 4 times 2 to the power 3. This is equal to 48 minus 32, which is equal to 16 centimeter cube. The radius of the sphere is 2 centimeter. How many of these spheres can be placed in a cube whose one side is 12 centimeter? And what's the volume of airspace that remains in the cube? Now here, the length of the cube is 12 centimeters. So how many spheres with a diameter of 4 centimeters can I put here? I can find 12 over 4, which is equal to 3 spheres. It's the same for the thickness, which is equal to 3, and it's the same for the height, which is equal to 3. So 3 times 3 times 3, I can put 27 spheres. The volume of airspace is equal to the volume of the cube minus the volume of the 27 spheres. So which is equal to 12 to the power 3 minus 27 times 4 over 3 pi r cube, which is equal to 864 centimeter cube. Let's find the volume of this geometrical object. When I divide from these parts, I have 3. rectangular prisms as V1, V2, and V3. V1 is equal to the length 3 times the height 1 times the thickness equal the same 1, so which is equal to 3 centimeter cube. The V2, here you see that this part is 4 centimeter and this is 3, so the rest, this part will be 1 centimeter. 1 times the height, I have 2 here, 1 here, 3, so the total height is 5, so I have 2 centimeter is given already here, times the thickness, which is equal to 1, so 2 centimeter cube. The volume of the third part is 4 times 1 times 2, 4 times 1 times 2, which is equal to 8 centimeter cube. So the total equal to 13 centimeter cube. The volume of this geometrical shape, and I divide from here, I have again 3 rectangular prisms. You see, have the volume of the V1 and V3 are the same, so I can say the height 8 times thickness 1 and width 1, so equal to 8 centimeter cube. The volume of V2 is equal to the width 2 times the height 0.5 times they have the same thickness as 1, which is equal to 1 centimeter cube. So the total will be 2 times 8 plus 1, which is equal to 17 centimeter cube. 2 solid cylinders are shown. The radius and the heights are given. What's the volume of the cylinder B in terms of the cylinder A? The volume of the cylinder A is equal to P times the radius r squared times the height h. The volume of B is equal to P times its radius is 2r, then 2r squared times the height 2h, which is equal to 8pr squared h. This value is equal to the volume of A, so the volume of B is equal to 8 times the volume of A. The B, we have the surface area question. The surface area formula is equal to 2pr height plus 2pr square. If we take in common parentheses of 2p, I have radius times height plus r square. So the surface area of A is equal to 2p times the radius RH plus r square. The surface area of B is equal to 2p times the radius 2r times the height 2h plus 2r square, which is equal to 2p times 4rh plus 4r square. So you see that this value is 4 times this value, so it is 4 times the surface area of A.